Hey folks, it's time to take on the heaviest of heavy-duty development tools for the TI-99, the UCSD P system, the expansion board that transforms your TI-99, turning Pascal into the native language of the machine, and building a whole disk operating system around it. Meaning, on a platform that went all in on solid-state software, the P system is your best option for going all in on disk-based software instead. The disk versus cartridge debate aside, BASIC and not Pascal was of course the built-in language at the TI-99, like it was for most micros of its era, which is why I talk about TI BASIC and what it can do so much on this channel. And the BASIC built into TI-99 ROM could do some pretty cool things. It was slow, and being based on Dartmouth BASIC via TI's mini-computers, it wasn't much like the Microsoft BASICs folks were used to. But it made putting color graphics on screen easy. And TI made it even better with Extended BASIC in 1981, adding sprites and speech and assembly subroutines, and all the things that were missing from TI BASIC in the first place. Still, none of that came any closer to making BASIC a real disk operating system. If you wanted to go beyond BASIC, you needed something more. And in the TI-99's heyday, the P system was TI's suggestion for a big upgrade that ditched BASIC for something better. UCSD Pascal is a highly structured, efficient programming language that is faster, more logical, and substantially more powerful than TI BASIC. With UCSD Pascal, you can write more efficient programs on your home computer, and you can take advantage of the many existing UCSD Pascal programs with little, if any, modification. So, with the P system, you're first off able to write programs in Pascal, but second, you can take advantage of existing software, and even be part of a larger P system user community. Just like TI user group newsletters kept the flame alive long after TI left the computing market, the UCSD P System User Society kept that niche going through the 80s, and the TI-99 was a member of that P System family. In 1983, the TI-DC user group told its readers, "A tremendous library of UCSD Pascal applications are available from the International UCSD P System user group. Terminal emulators, word processors, other programming tools are all available. Games, too." The reason that's possible being that the P system runs code on a virtual machine called the P Machine emulator, and that virtual machine lets P system versions on different CPUs run a standard bytecode. So, as far as cross-platform compatibility goes, the P system kind of lets you have it both ways. It lets you use native TI-99 features in your own programs.
I am a computer.
But it also lets you run 40-column text mode P system programs as if they were native applications. And that 40-column text mode as the TI P system standard graphics mode is one thing that might stick out at first glance. Instead of the 32-column graphics mode you're used to from TI BASIC, all the core P system programs run in 40 columns. And by default, your programs will run in 40 columns too. That makes a whole lot of sense for most programs. And honestly, it doesn't make a whole lot of sense that for the most part, text-driven BASIC and XB programs only ever had 28 columns to work with. These days, we've got T40XB to give us 40-column BASIC, and I've enjoyed taking advantage of 40-column graphics that way myself in recent times. But back in the day, the fact that the P system gave you easy access to 40 columns right out of the box was definitely a bonus. That's just your default screen mode though, and any program can switch to 32-column color graphics on demand, thanks to a library of included TI subroutines. Using the support unit, you can switch to 32-column anytime you need to. Or you can even use the seldom seen multicolor mode if you like, which is pretty useless, but fun they left that in there, I guess. The other libraries you're likely to use are sound, sprite, and speech, which add exactly what it sounds like those add. But you're not likely to need them in every single program, so it makes sense to leave them out when they're not needed. And at this point, the cross-platform compatibility idea does seem a little dubious, right? Because clearly we're taking advantage of these extensions, which are just plain essential for making a TI-99 act like a TI-99. If I had a Pascal for TI-99 without speech, music, color, or sprites, I'd give it a pass. I'd go back to using Extended Basic, which can do all of those things. Or maybe even TI Logo, where I can do all of those things except speech, but where I get turtle graphics in the bargain too. So, code portability does go by the wayside. But them's the breaks. At this point in history, that's probably fine. No disservice is being done to the larger P-System community. So thanks to these extensions, which we are definitely using, you get all the graphics and sound features you'd expect from your TI-99 to use in your P-System programs. You just won't also be able to run the same programs on your PDP-11 or your Apple II. So we've got sprites, and we got a pretty powerful set of routines devoted to handling them. But the big question is, does Pascal let me use them more effectively than XP does? So let's do a test with a program that moves 4 layered sprites, 1 pixel at a time, in tandem, as fast as Pascal can manage. And let's compare that to an XP program that does the same thing. And the verdict is, Pascal does beat XP's sprite update efficiency, while offering a lot more flexibility in the way it handles sprite data. Ultimately, P-code can never be as fast as assembly, as a bytecode interpreted by a virtual machine, but it's absolutely faster and more flexible than BASIC or XP. But for more confirmation of that, let's take a Pascal program that does pretty much the most common thing a TI-99 ever does: writing a tile to screen. In this case, writing them one after another to all 768 screen locations. Just writing a byte at a time to VDP. Compared with the TI Basic program using the call hchar command, P-code is way faster, unsurprisingly. Then, compared to an Extended Basic program using XP's faster version of call hchar, still way faster in P-code. Then finally, if we compare it to TI Logo's even better optimized put-tile command, even then, still faster. So the performance you get out of P-code does indeed fall somewhere between a high-level language and assembly, like you'd expect. But the upside for me is the system itself as much as the speed. It's the way the P-System gives you an entire disk operating system with every development tool you could ask for well integrated, with tools for sector editing, disk formatting, error checking, analysis of compiled code, and all that good stuff. It's the fact that when I get an error, the P-System compiler offers to take me straight back to the editor at the line that generated that error so I can fix it. And heck, as a disk operating system, the P-System doesn't even limit you to programming in Pascal. Pascal compiled to bytecode is definitely the main point here, and that has led to P-System being misunderstood as standing for Pascal System quite a bit over the years. But the P-System supports development in assembly too, and in other high-level languages besides. TI Pilot being another option TI offered. Not a language many folks used or even knew about back in the day, but another language you can write and run on your TI-99 with the help of the P-code card. And the delightful thing about TI Pilot to me is, Pilot programs are interpreted by the Pilot interpreter, which is itself a P-code program interpreted by the P-machine emulator. So, on a platform whose BASIC was criticized for being double interpreted, yes, that's right, TI found a way to double interpret Pilot, too. Talk about staying on brand. Pilot's a simple language, but since it's P-System software, it does actually come with all the same library support Pascal gets. And so, while it's simple to write, it can do color and sprites and sound and speech, making it surprisingly full-featured.
Hello.
Still, Pilot is not the point of the P-System, as I say. Pascal and the tools the P-System gives you for creating powerful Pascal programs are the point here, with the tool you'll spend the most time in being the P-System editor. That offers a pretty impressive editing feature set, with features like find and replace, and cut and paste, and jumping to markers in the code, all available on the P-System prompt line there. That prompt line is the constant interface feature of the P-System, where you'll find your main options on any given screen. So on the main menu, for example, the prompt line is where you'll find your main system features, the compiler, editor, and filer, being the three you'll use the most. Rather than having you type words at a command prompt, the P-System uses the prompt line's branching tree of one-key commands. E for editor, X for execute, and so on. So getting used to those hotkeys is half the battle of learning the P-System. But once you got the hang of them, they're a really efficient way to get around. So for example, when you're done editing a file, press Q to quit, then press U to update the work file, then press C to compile, then finally R to run. And for a small program, you can get yourself from editing source to executing compiled code in under a minute. But none of these design features are TI-99 ideas. This is all the UCSD P-System version 4. As you'll see on the boot screen when you start up the P-System, and as you'll see on the label of the P-code card itself, which you'll need to install in your PEB to get things up and running. Yes, you need the P-code PEB card to get off the ground with the P-System, and you'll need the 32K memory expansion in your PEB too, or the system won't start. And what's more, since this is a disk operating system at the end of the day, you'll need a disk controller and at least one disk drive. Or, as TI confusingly calls them, a disk memory drive. In practice, though, 2 disk drives were strongly recommended by TI, and, in my own experience, they're needed to properly use the P-System. Reason for that being, the P-System comes with 4 disks, and the compiler disk and editor filer disk are 2 of those that you'll use constantly. So, if you don't have 2 drives, the swapping can be a royal pain. But as long as you've got a drive for each of those disks, you can get to work without too much hassle. And what hassle there is, well, we can blame on TI's standardizing around single-sided, single-density disks. Just fine for 1979, maybe, but by the mid-80s, a bit behind the times. Once you're using the P-System, you can check your disks using the filer's V option for a volume list. And you can see here, disks 1, 2, and 3 are accessed as P-System volumes 4, 5, and 9. So anytime you need to write a path in the P-System, it's going to be number 4 for disk 1, instead of the DSK1 prefix you might be used to from BASIC. Now if you're like me, these days you've probably gotten used to using the TIPI for all your TI disk and file management needs. But you can probably guess from what I've said, that's not going to do the trick with the P-System, which doesn't use the TI disk format at all. Try to view a P-System disk in TI Disk Manager, and all you'll see is a file called Pascal. Not much help, but it's all you'll get from anything that tries to look at a P-System disk as if it were a TI disk. So with the P-System, you need actual floppy drives, or otherwise Gotek drives that'll act like them. And in my case, it's one real floppy drive and a Gotek drive that can toggle between P-System disks as needed. Being able to just spin the dial to switch P-System disks makes for a tolerable sort of floppy swapping, I find. One more side effect of the P-System disks being their own format is, if you're looking to work with P-System disks on PC, popular tools like TI-dir and TI-image tool won't do any better than TI Disk Manager did. But happily, someone created a program just like those ones, but for P-System disks specifically. So, P-code tool can read your P-System disks and grab file contents as needed. You can find that link in the description. That is a must-have program in the P-System world, I'll say. Between a Gotek with flash floppy firmware and the P-code tool program, you've got a PC tool that can read and write P-System disks, and a TI drive that can read and write P-System disks too. So you're pretty much covered when it comes to bridging the gap between the modern world and the P-System's 1979 one. With the PEB 32K expansion, TI disk controller, and at least 2 disk drives, at least one of which is a flash floppy Gotek, we've got ultimate Pascal programming power on the TI-99. Easy as can be? Not really, but it's doable. There is just one more thing that might get in the way of that, and that's best described in a 1985 Computer Shopper article. That article asks, did your P-code card die? Chances are good that the 74C245 on the P-code card blew out. The suggestion here being, before you take your TI card to the exchange center to get it fixed, try replacing the 245. A $2 chip is better than shelling out $20 or more on a replacement card. So yes indeed, a lot of P-code cards did have component issues. But yes indeed, they seem to be fixable. And if you don't feel up to fixing one yourself, or you just don't have one to begin with, our main TI community vendor, Arcade Shopper, has been repairing cards lately. So check him out for working cards, as he's likely your best bet. These issues might have been specific to one production run, as back in the day 99.4 Users of America reported, "Pop goes the diode! We've found a 100% failure rate on P-code cards manufactured the 52nd week of 1982. And, as it happens, I can confirm I have a P-code card with that date stamp and that issue. So I'm inclined to think that's true. Anyway, if all these frustrations of working with 40-year-old hardware just seem like a lot, let's be honest, you might want to emulate the P system instead. And you can do that under either MAME or Classic 99, easily and accurately, with Classic 99 usually being the easier of the two. Just select P-code card from the cartridge menu under Apps, then make sure the P system disk images are selected, probably with the compiler and editor disks in Drive 1 and 2, and the utilities disk in Drive 3. Then restart, wait for the boot sequence to complete, and edit, encode, and compile away. But I wanted to make that dead easy for anyone looking to poke around in the P system, so in the description I've linked a pre-configured install of Classic 99 which will boot into the P system with disks already loaded. Just unzip, start Classic 99, and you'll be inside the P system with compiler, filer, and editor available. Not quite the real thing. The roar of the PEB fan will be missing. But it's a great place to start when the real thing is so hard to come by. And you can always copy your work to a GoTech if real hardware ever does enter the picture. The only danger is, if you get used to hugely saving on compile time by putting Classic 99 into overdrive mode, it may get hard to pass that up. Sometimes, actually touching a TI-99 can seem unnecessary to developing for the system in the present. Our cross-development tools are just too good. But I think the P system makes a strong argument for the original tools being pretty awesome sometimes. Everything just ties together really nicely. When you update your work file in the editor and open the compiler instantly knows where to look for it. And heck, if you try to run a work file without compiling it, the P system will recognize you're a moron, take pity on your worthless human soul, and compile it for you automatically, so it can run. Because the P system knows what you want better than you do. So this is a platform for folks who want power tools for developing programs for 1979 hardware in a 1979 way, using the best in 1979 disk operating system development tools, instead of the dumbed-down experience sold to the average home user. In the past, the most unappealing thing about writing software for the P system was just that you were writing software for a platform that almost nobody could use. But I like to think the miracles of modern retrocomputing are changing things. Now, giving someone a working pre-configured P system installation is as easy as giving them a zip of Classic 99 set to boot the P system with disks loaded. And now, transferring a P system work disk to a real hardware setup is as simple as copying it to a USB drive. But maybe most importantly, now that issues with P-code cards failing have largely been figured out, folks willing or able to do the repairs can do them, and PEBs in need of P-code cards can get them. So see the description of this video for the P-System manuals, and for that classic 99 install that'll get you up and running on the P-System if you do want to mess around with it and see what the P-System can do. Thanks for watching, folks. Did you use the P-System back in the day? Or did you see one used? Or was it like it was for me, just a mysterious power tool outside of reach? Tell me about it in the comments. And see you next time. Until then, keep on partying like it's TI-99.